Hello and welcome to the TTI Distribution Download, the podcast where we talk about all things happening in the world of electronic components with the specialists of TTI.
Thanks, Jim. Hey, everybody, and thanks for plugging into the TTI Distribution Download. I'm Steve Brahosky. I'm a business development manager here at TTI, been in the electronics industry for over 30 years, and I'm joined here today with Pat Denton, TTI Technical Marketing Director, and Pete Pitlick, who is a Senior Manager, North American Field Application Engineering at Littelfuse. Littelfuse being one of our premier circuit protection partners. So welcome back. Today, Pat and Pete are going to talk about overvoltage protection. Our last episode dealt with overcurrent, so today it's overvoltage. With that, I'm going to turn it over.
Thanks, Steve. I'm Pat Denton, Director of Technical Marketing here at TTI. Pete, let's pivot over to overvoltage protection. When I think of overvoltage protection, I think about lightning and ESD. Can you further explain the need for overvoltage protection?
Sure. As we were talking about overcurrent, where we're looking to protect against overcurrent type fault scenarios, now what we're protecting against is overvoltage. Generally, when we say overvoltage, those are going to be transient type conditions. So you're exactly right. Lightning-induced transients. They're also switching type transients, generally referred to as EF2, electrical fast transients. And there's also ESD, which we'll talk about on a different episode, that also falls under overvoltage, but generally that is a much shorter time scale. So again, going back to overvoltage and transients, two main will generally be lightning-induced transients and switching transients.
Perfect. And can you go over the different overvoltage protection technologies that Littelfuse offers?
So the different types of technologies, we can group them into a couple different categories. The first would be clamping type devices. And these would consist of an MOV, metal oxide varistor, and a TVS, a transient voltage suppressor. The other category would be crowbar type devices. These would generally be a GDT, gas discharge tube, and a sedactor. Now with crowbar devices, such as a GDT and a sedactor, and again, a sedactor just being a solid state version of a gas discharge tube. When the transient is in the circuit, when a crowbar device turns on, it will shunt that energy to ground. So very little is dissipated in the device itself. When we look at clamping devices, again, MOVs and transient voltage suppressors, the vast majority of the transient will now be dissipated in the device. And depending on the transient that we're trying to protect against, the magnitude and the duration, in some applications, you may want to use a clamping device, and in other applications, you may want to use a crowbar device.
I'm interested in how you choose which those are. So of those technologies, can you expand on the construction as well as the characteristics of those technologies?
Sure. So if we take a look at clamping devices again, metal oxide varistor, basically a zinc oxide sinter type material. Vast majority of energy will be dissipated in the device. MOVs you'll typically see used on the AC side. About probably 90% of applications. If you were to take a look right at the incoming circuit, generally what you'll see there is a series fuse. And then right after that, you will see a parallel MOV. Transient voltage suppressors, generally used on the DC side. They can also be used on the AC side, but for most applications, you'll find those on the DC side. Gas discharge tubes and sedactors, crowbar type of devices. Generally, they'll also be used on the AC side. Now, why would we want to use one versus another technology? It really depends on what level of protection do we need in the application. So some applications, electronic components, will be more sensitive than others. So we may need to do a combination of different technologies. We may need to put an MOV in series with a GDT. Again, this will be in parallel across the line. We may look at doing an MOV plus sedactor, or in some cases, we may actually do a staged protection scheme where we use an MOV plus GDT. We'll use a series inductor, and then we'll incorporate a second stage. And that second stage may also be an MOV plus GDT or an MOV plus a sedactor. And again, what we're trying to achieve there is when that transient first presents itself onto the circuit, again, this can be in the thousands of volts and even thousands of amps of short circuit current available. We want to bring that voltage down below the damage threshold of the electronics we're trying to protect. So if a single stage is not adequate to bring that voltage down, we'll use, again, a staged approach. And that second stage will bring that voltage even lower. So again, really what we're trying to do at the end of the day is protect the end application, bring that transient below the damage threshold.
And getting back to the ever-present compliance standards, are there different standards for overvoltage protection than we had for overcurrent?
So when we look at overcurrent, we went over a few different standards that are applicable, both product and end product standards. The same can be said for overvoltage components. So the components are designed to and need to be certified to a standard, but also the end applications. There are different application standards. These application standards define what the threats are, what the magnitudes are, what the durations are. So depending on what end standard the customer needs to meet, that also in some cases will dictate what overvoltage protection device we will use. So just to mention a few, which really are applicable about 70 to 80% of the time, UL 1449 for surge protection devices. So not only do our devices, overvoltage protection devices, need to be certified to, but also the end product. There's also IEC 62368. This is a recent standard. Basically what that standard is merged a couple other standards for overvoltage. Okay, and those are mainly applicable to audiovisual equipment, also to communications, telecommunications applications. So those got merged into the one standard, 62368. It was a little bit more complex than just a merger. There was really different engineering principles that went into defining those. So those were mainly hazard-based standards. So making sure that when components are selected, and also other components, not just protection in the application, they can adequately protect the end application, but also so they're not overstressed in that application. So we're looking at putting in additional margin. So yes, so there's different types of application standards. One for the devices, the products themselves, and then also end product standards, which really define what that environment is. And then from those standards, the designer can choose appropriately which device to use.
I'm so glad we have you guys as experts to help us get through the different standards. And going back to the circuit design that we talked about before, can you walk us through the methodology for selecting overvoltage protection?
Sure. So let's take a look at first an application where we're looking to protect against the incoming AC power. So the first thing a designer will look at is, are there any applicable end product standards that they need to meet? And generally 95% of the time, there will be one. And that standard, again, will define what that magnitude, duration, and in some cases, pulse waveform, that end application needs to be protected against. So now knowing what those specific conditions are, a designer can look at various overvoltage protection devices. And again, on the AC side, generally that'll be an MOV. So now knowing the voltage, the currents, we'll look at an MOV specification, make sure it is capable of actually being able to suppress that magnitude, duration, and pulse width. And also, as I mentioned previously, to be able to clamp that overvoltage condition to be below the damage threshold, again, of the electronics that we're trying to protect. So again, depending on that end application, designer may select an MOV, it may be a GDT, it may be a combination of both. Again, very important to reference the standard, and then I'll also look at the parameters and different specifications of each individual device to make sure that you can first be able to withstand that transient, and second, again, to clamp and protect below the damage threshold of the electronics.
So Pete, tell me, does Littelfuse offer any application testing services?
Yes, we do. We do have global application labs. So when we are working with the customer, designing in circuit protection, the customer can send that application to our labs. Generally, this will be a circuit board. It may have various components. It may be overcurrent, it may be overvoltage. And then what we'll do is we'll test to the applicable standard. So first, it's to make sure that the application is adequately protected. And second, so when the customer needs to take their application for official certification, there is a very good degree of confidence that they will pass. So it is a service that we offer globally, and we do that very often with customer applications.
Excellent. Yeah, thanks. Great service. One more question. Do the compliance standards you mentioned earlier define or dictate which technologies would be used in certain applications?
One of the first things a designer needs to do is to take a look at what are the applicable standards for their end product. And those standards will define the threat and the magnitude of that threat. So now that we know what the threat condition is, the appropriate overvoltage device can be selected. And this again may be an MOV, maybe a GDT, it may be a SEDAC or transient voltage suppressor, or a combination of those devices. So standards are very important when it comes to the selection, again, to make sure that the end product application is being protected.
Hey, thanks, Pat and Pete, again, for sharing your knowledge and insight, in this case on overvoltage protection. We really appreciate it. As Pat mentioned earlier, it's really good to have a partner in Littelfuse who can help share the knowledge as well as apply the knowledge with our customers as they sort through their applications. I want to thank everyone for joining us today on the TTI Distribution Download and ask you that you tune in again for our next session with Littelfuse, which is on electrostatic discharge. Thank you.
That's it for this episode of the TTI Distribution Download. For more information on any of the topics you heard about today, reach out to your nearby TTI branch at 1-800-CALL-TTI or visit us online at tti.com.